So, calculate the volume of 0.01 grams of hydrogen gas at RTP. If you love maths, then you will like how this works out. So the first thing that we need to do is work out how much 1 mole weighs and what its volume would be. So 1 mole, we say to ourselves, 1 mole of H2 molecules or hydrogen molecules contains 2 moles of hydrogen atom because it's H2 and they're joined together in a compound. Therefore, 1 mole of hydrogen weighs 2 grams and takes up 24 decimeters cubed. We then just substitute in the numbers into our triangle. So we do 0.01 divided by 2 times by 24. If we put that on our calculator, 0.01, divide it by 2, then we times that by 24. That gives us 0.12. 0.12 decimeters cubed. Now, if, like me, maths is your kryptonite, that's okay, because if we love chemistry, we don't panic, we just follow the magic triangles through. We draw out our table, mass, moles, MR, and we also can put in the volume here. We could add 24 to our table, but 24 is always just 24, so it's kind of a waste of energy, really. We put in what the question tells us, that we want to calculate the volume of 0.01 grams. So we put in that we have 0.01 grams, and then what we do is we've got the mass, so we just do MR times the moles. We do the mass divided by the MR to give us the moles. So we say 0.01 divide by 2. It gives us 0.005 moles of hydrogen. Then, now that we've got the moles, 0.005, it's really easy to times by 24. So we do 0.005 times by 24. We just keep it on our calculator and go times by 24, and we get 0.12 decimeters cubed, which, as you can see, gets us the exact same result as we got up here in the mathsy way. It's just that it's easier to follow through. You only have to remember your magic triangles. You have to remember the maths way of doing it. So if you can't see mathematics, if you can't see how it works, just use your triangle. There is no shame in using your triangles and your table method at all. So what about if they ask you to calculate the mass from the volume and you absolutely love maths? Then actually relatively straightforward if you love maths, because you can work out the mass of 1 centimeter cubed by dividing by 24,000. So you've got 100 centimeters cubed of carbon dioxide. So you just do 100, not 1,000, sorry, 100 divided by 24,000. Because you've got 100 centimeters cubed. So 100 divided by 24,000 gives you 0.00416, 0.00416. Then you can just leave that calculator value, 0.00416, and then you times that by the MR of carbon dioxide, which is 44, and that will give you 0.183 grams. But if that doesn't make any sense because you're getting lost up here, that's completely understandable. Just follow your table method. So calculate the mass of 100 centimeter cubed of carbon dioxide. The easy way, you just say, if I know my volume and my volume is in centimeters cubed, then I need to convert to decimeters cubed. To do that, because I'm going centimeters cubed to decimeters cubed, I need this number to be smaller. So if it needs to be smaller, I need to divide by 1,000 because there's 1,000 centimeters cubed in a decimeters cubed. So In this case, the first thing I do is convert my centimeters cubed to decimeters cubed by doing 100 over 1,000. 100 over 1,000 gives me 0.1. Then I've got my volume in decimeters cubed. If I divide my volume by 24, I get my moles. So I do 0.1 divided by 24. And that gives me 0.00416. Then I keep that on my calculator, and all I've got to do, now I've got my moles, I just need to times it by the MR to get my mass. So I times by 44 because that's the MR of carbon dioxide, and I get 0.183. 0.183 grams, which is exactly the same as I got in my mathsy way. It's just that that's a lot simpler. Well, it's a lot simpler in my head. You may find that that's a lot simpler for you. And if that's the case, do it that way. There's no right or wrong way. There's just an easy way for your brain. So from now on, because the easy way for me is the table method, from now on the walkthrough, I'm just going to be using the table method. If the mathsy way works for you, you can just check off your answers versus the answer I get with the table method, because I just really don't want to do two different ways. Hopefully, the explanation should show you either way how to do it. Right, okay. 20 centimeters cubed, 200 centimeters cubed, sorry. I need to divide by 1,000 to get into decimeters cubed. So 200 divided by 1,000 gives me 0.2. If I've got 0.2 as a volume, 0.2 decimeters cubed, I can divide that by 24 to get my number of moles. So 0.2 over 24 gives me 0.008 moles. Now I've got the moles, I just need to times by the MR. So 35.5 times by 2 gives me 71. So I just times that by 71. And that will give me my mass of 0.592. 0.592 grams. Calculate the volume occupied by 0.16 grams of oxygen. So in this case, I need to work out my volume, and I am given the mass. So I'm calculating the volume given 0.16 grams of oxygen. So I just know 0.16 grams is what I've got. I need to do the mass divided by the MR to get the moles. Well, oxygen is 16 times 2, which gives me 32. So 0.16 divide by 32. 32 gives me 0.005 moles. So 0.16 over 32 gives me 0.005 moles. Now that I've got my moles, it's very easy. I just do 0.005 times by 24, and that will give me, back the other way, 0.12 decimeters cubed. Remember, it's always in decimeters cubed, never centimeters cubed. What is the volume of 3.5 grams of hydrogen? So I'm looking to find the volume again. Here I need to put in my mass that it's given me in the question. Mass divided by MR. 3.5 over the MR, which is 2, because it's 1 times 2, gives me my moles, which is, oh no, that's not what I want. 3.5 divide by 2, that's better, 1.75, and now I've got my moles. All I need to do is times that by 24, and that will give me, so 1.75 times by 24 gives me 42 decimeters cubed. Okay, feeling smart. Again, this is harder than you will get in the exam. So if you've watched up to this point and you're like, yeah, okay, I think I can do what's going to come up in the exam, then you can just switch this off now. You don't need to go any further. All of this is kind of beyond the scope of the syllabus. They're never going to give you questions that are this difficult. But if you fancy a challenge, let's play together. So we've got 6 grams of a mystery hydrocarbon gas, and it has a volume of 4.8 decimeters cubed. Calculate its MR. Well, if we're calculating the MR, we need to have 2 pieces of information from the triangle. Well, we can work out the number of moles using the blue magic triangle by doing volume divided by 24. So if we say 4.8 over 24, that will give us that number of moles. 4.8 divided by 24. That gives us 0.2 moles. Now I have the moles and the mass. So I can say mass divided by the moles gives me the MR. So 6 divided by 0.2. I need to clear my calculator. 6 divided by 0.2 gives me 30. So my MR is 30. Now, we know it's a hydrocarbon gas, so we know it can only have carbon and hydrogen only because it's hydrocarbons and they only have hydrogen and carbon in them only. So I'm going to guess that it's probably 2 times 12. That will give me 24. And then what's left over, I can only make up with the hydrogens. So I'm going to say I've got another 6 left to make up. So I'm going to probably be 6 times 1. And that will give us another 6. 24 plus 6 gives us 30. So it's probably C2H6, which would look something like this. 1, 2, 3, 4, 5, 6. So actually, it would be ethane. But don't worry if that's a little bit confusing to you because we haven't done organic chemistry yet. Calculations from equations involving gases. So, calculate the volume of carbon dioxide evolved at room temperature and pressure when an excess of dilute hydrochloric acid is added to 1 gram of calcium carbonate. So, because it says excess, we don't need to include the HCl at all. It's a moot point. We've got way more of it than we can actually need. So let's not highlight it. Okay? Let's look at what it's asking us about. It's asking us about the volume of carbon dioxide evolved when 1 gram of calcium carbonate is used. So we just plug in what we want. We've got 1 gram of calcium carbonate. MR of calcium carbonate is 100. So we do 1 divided by 100 to get the number of moles. 1 divided by 100 gives us 0.01. We've got a 1-to-1 ratio in our balanced equation. So I've got 0.01 moles of calcium carbonate. I've got 0.01 moles of carbon dioxide. Therefore, I can do 0.01 times by 24. So 0.01 times by 24, that will give me 0.24. Okay, given the equation, what volume of hydrogen is formed? So what volume of hydrogen is formed when 3 grams of calcium is dissolved into excess hydrochloric acid? So I look at my equation, I check that it's balanced, and I put in what the question tells me. I've got 3 grams of calcium. The MR of calcium is 40. I can do 3 divided by 40 to give me my moles. Let's do that. 3 divided by 40. 0.075 moles. I've got a 1-to-1 ratio between my calcium and my hydrogen. So if I've got 0.075 moles of calcium, I've also got 0.075 moles of hydrogen. Now I need to find the volume of hydrogen. So if I know the moles already, I just times it by 24. 0.075 times by 24 gives me 1.8 decimeters cubed. What volume of hydrogen is formed? So I'm looking at the volume of hydrogen when 0.25 moles of hydrochloric acid reacts. Again, I say I've got 0.25 moles. I put in what the question already tells me, and I'm looking to calculate the volume of hydrogen. So I'm just going to use my magic triangles. If I have 0.25 moles of hydrogen, then I've got a 2-to-1 ratio. I've got 2 moles of hydrochloric acid for every 1 mole of hydrogen. So I've got 0.25 divided by 2. 0.25 divided by 2. That gives me 0.125 moles of that. Once I've got my moles, I just do 0.125 times by 24. That just gives me my decimeters cubed, or my volume of hydrogen evolved. So given this equation, how much magnesium is needed to make 300 centimeters cubed of hydrogen gas? So I'm going to look at my balanced equation. It's a 1-to-1 ratio. I've put in what I already have already. I've got 300 centimeters cubed. I'm not going to fall into the trap of putting 300 in there because I know that all volumes have to be decimeters cubed. So I'm going to do 300 divided by 1,000 to put 300 centimeters cubed into decimeters. So 300 divided by 1,000 gives me 0.3. Now I know I can times my volume, divide my volume by 24, will give me my moles. So 0.3 over 24 gives me my moles. Oh, I don't want to times. 0.3 divide by 24 gives me my number of moles. So I've got 0.03, 0.00, I apologize, 375. But I'm just going to keep that on my calculator. I'm going to say I've got 1-to-1 ratio. That means I've got exactly the same number of moles over here. Now all I can do is times by the MR, which I know is 24, and that will give me my mass of magnesium. So I times it by 24, and I've got 0.09 grams of magnesium needed. A small teaspoon of sodium hydrogen carbonate weighs 4.2 grams. Calculate the moles, mass, and volume of carbon dioxide formed when it is thermally decomposed in the oven. So I know I've got my mass of sodium hydrogen carbonate, and I need to calculate the mass, moles, and volume of carbon dioxide formed. So let's put in what I know already. I've got 4.2 grams. I know I've got a 2-to-1 ratio because my balanced equation tells me. So the MR of sodium hydrogen carbonate is 23 plus 1 plus 12 plus 16 times 3. That gives me 16 times 3 plus 13 plus 23. 84. So I can do 4.2 divided by 84. And that will give me 0.047. 0.047. And I've got a 2-to-1 ratio, so I need to divide by 2. That will give me 0.023. Notice how I'm not really rounding here because I'm keeping my calculator value. So as long as I'm keeping my calculator value, it doesn't really matter whether I round and worry about those kind of things in my table method because I know that I'm keeping my calculator value anyway. If I want to find the volume now, then I can do the moles times by 24. So I just times my calculator value by 24. and that will give me 0.572, 0.571, 0.571 decimeters cubed. But I also need to find the mass. So the mass of carbon dioxide is 12 plus 16 times 2. So that is 32. That's 44. 44. So now I can also do I'll get my actual unrounded version of moles back first. Divide by 84, and then I'm going to times it by, I'm going to divide it by, Mrs. Baker. 4.2 divided by 84 gives me my moles of sodium hydrogen carbonate. I divide that by 2 to get my moles of carbon dioxide, and then I times that by the MR, which is 44, and that will give me 1.1 grams. So now I've got everything that I need. I've got the mass, yes. I've got the moles, yes. And I've got the volume, yes, of carbon dioxide. What volume of carbon dioxide is formed at RTP when 5 grams of carbon is burned? So I'm looking for the volume of carbon dioxide, and I've got 5 grams of carbon. So I just put in what I know. 5 grams of carbon, the MR is 12. The MR is 44 over here in case I need it. So I just do 5 divide by 12. That'll give me my moles, which is 0.416. I've got a 1-to-1 ratio, so I've got 0.416 over here. I'm looking for the volume, so I didn't actually need to put in the MR at all. I can just do 0.416 of moles times by 24, and that will give me 10. So 0.416 times by 24 gives me 10 decimeters cubed. So last but not least, what volume of carbon dioxide gas is formed at RTP if 1 kilogram of pure propane gas fuel is burned? So again, we just plug in what the question tells us. This is C3H8, and the ratio is 3 CO2. So I've got a ratio of 1 to 3. So I know that I've got 1 kilogram. Well, because I'm converting between two triangles, it's not like before when I only had one triangle, the red mass moles MR triangle. I need now to convert this into grams. So I do 1 times 1,000 gives me 1,000 grams of carbon dioxide. I can do 1,000, my relative molecular mass is 12 times 3 plus 8, which equals 44. So I just do 1,000 divided by 44. Oh, that's my son WhatsApping me. A YouTube short, I think. Equals 22.27 moles. Because I've got a 1 to 3 ratio, I do 22.27 times by 3, but I keep my calculator value so I don't get a rounding error. So I times that by 3, 68.18 moles of carbon dioxide produced. Now I've got 68.18. I can times that by 24, and that will give me my volume, which is equal to 1,636 decimeters cubed. Wow, that's quite a lot. Hope that was useful to you. See you later.